Hello, I'm Paul Cox, your host for the first of three special star parties where we'll be learning about the sun, our local star. And in this episode, we're going to look at the solar activity cycle, the features you can capture using Slooh's solar telescope, how to access the solar telescope and snap images, and our Quest learning activities where you can learn more about the sun. Now, in the next episode, we're going to learn about the other solar features and events that we can't see with Slooh's telescopes. Now, some of these pose a threat to our satellites, our power and communications infrastructure when Earth is bombarded by high energy particles released from the sun. We're going to learn about those events and their potential threat in episode 3. But don't worry, it's not going to be all doom and gloom. Some of that solar activity is also responsible for one of the most beautiful and ethereal sights we can witness in the night sky, the aurora. And that's what we're looking at here, which was from an eclipse visit that I did in 2015. Now, let's get started. I would like to welcome Slooh educator and our expert guest today, Keith Wozleski. Welcome, Keith.
Thank you, Paul, for having me.
Now, let's get straight underway and start by talking about solar cycles before we learn about the solar features and activity that we can capture using Slooh Solar Telescope. So, Keith, solar activity increases and decreases over time. Can you tell us a
Yes,
little bit
it
more about
does.
that?
Yeah, so we go through a solar cycle begins where we have basically no solar activity for quite a while. And then we start to see the appearance of these black spots on the sun, which we call sunspots. These will become more and more frequent. We'll see more of them. Usually they start in the top part of the sun and will gradually make their way down to the belly of the sun, the equator. And these represent areas of magnetic activity. For a solar cycle, about 11-year period of time. So the solars will start seeing sunspots, and then they'll become more and more frequent. And right now, we are pretty much right in the middle of the cycle, and that's why we're seeing all this ramped up activity on the sun. The cycle's about
Exactly.
midway through.
Exactly. We're seeing such superb solar features at the moment in the telescope every day. But so we reckon that we are roughly coming up to or are actually at the peak of the solar cycle at the moment.
That's the estimate. The cycle can vary between 10 to 12 years. 11 years is kind of the average. But the estimates now are anywhere from June to November. We're going to expect to see this peak activity. Again, more and more sunspots. And in fact, in the past, we saw an enormous sunspot active region. So it's definitely ramped up.
There's some weird things, aren't there, that happens with the sun's magnetic field during this cycle?
Yeah, let's take a look. So the sun does have an overall magnetic field. So just like the Earth, we have a North
Okay.
Pole and a South Pole, and we have these magnetic field lines. The sun also has an overall magnetic field line. But that will change as these sunspots begin to gravitate towards the equator. The magnetic field becomes blurred and becomes confused, and the poles will actually swap, where the South Pole will be on the north. And
Okay.
as the solar activity decreases, we go to a period of inactivity. And again, the solar cycle will start all over again. So in another 11 years from now, that polar arrangement will reverse again. The sun isn't flipping, it's the polar alignment of the sun, or the alignment of magnetic fields, that's actually swapping here. So
Okay.
the last time I did this was 2013, so we're ripe for it right now.
This is, if anybody's new to Slooh at the moment or thinking of joining, this is a superb period to join because we have seen just extraordinary activity, and we'll talk about some of the features. But talk about this particular animation here, Keith.
Yeah, so this is an animation that you did. So I mentioned that we have an overall magnetic field, but because the sunspots appear in groups and the plasma, which bubbles up in the surface of the sun, is ionized and forms magnetic fields, we have magnetic field lines all over the surface of the sun. So it's not just the overall magnetic field. There are millions of these magnetic lines that become tangled and confused and wrapped around, and some of them become fragmented and broken. And it's these magnetic field lines that contribute to the solar activity that we see on the Slooh telescopes. It is the key that drives all of this activity, the magnetic field.
Yeah, it's the engine, isn't it? So, Keith, anything more about solar cycles before we go on to talking about solar features?
Yeah, I would say just keep an eye on what's happening. Definitely, as you said, this is the time to start watching the Slooh Solar Telescope. If you haven't before,
Mm.
great, great stuff. We've been treated to so many incredible things. We're going to look at some of them next, but a study all its own, and we're, a worthwhile endeavor without a
Yeah, and
doubt.
we're going to talk more about this in future episodes, but only this week we saw one of, as you say, that one of the largest sunspot groups that we've seen for. Well, I don't think I've seen anything quite that large. But anyway, let's get on to our main topic for this episode: the solar features Slooh members can capture using Slooh's special solar telescope. And that's located, if you don't know, at our flagship observatory, the Institute of Astrophysics of the Canary Islands, on top of an 8,000-foot volcano. And that's where this particular image was snapped from. But the telescope can view two layers of the sun, kind of, Keith. The first of which is the photosphere. Can you tell us what that is and the features that we can see on that?
Sure. So the photosphere is the actual surface of the sun. We think of the sun as having a surface, even though it's a giant ball of gas and it's very explosive, but it's not at all like the moon. But we using the white light filters that we can use with Slooh, we will see a type of surface, and that's where we see sunspots.
Yeah.
Can also dial in and adjust it to look at what we're looking at here, the chromosphere, which is the sun's atmosphere. So if the photosphere is thought of as the surface of the sun, this would be the atmosphere like we have on Earth.
So we can see a whole raft of features on this. I mean, it looks, fairly chaotic, but what can we see? What are we actually looking at here then, Keith?
Yeah, we've got so much going on. So I'm glad that we looked at those tangled magnetic field lines because we
Yeah.
see them in action here. So the first thing I think we'll look at is we can see those sunspots. If they're large enough and bright enough, we can see these darkened areas that basically look like a spot. That's why they're called that. Sunspots usually occur in pairs. So there is a North Pole and a South Pole. So here we see a cluster of 4 sunspots to the left. I don't know if you're seeing my mouse, but I've got the mouse here. Uh, 4 sunspots here, groups of 2. So that's the first main feature that we see. Yeah, the sunspots. Then we see larger active regions. This is where we would have just above a very, very bright area that we would call a plage. These have different magnetic field lines. These are usually going straight off the surface of the sun,
So
not
so so there's a whole stack of terminology in there
okay.
already. So an active region, I'm assuming the active regions are where we're seeing the sunspots, that bright area above it, that very, very bright area down at the kind of 4 o'clock position. Those are all
Sure, the 4
active
o'clock
regions,
position.
are they?
Yeah, let's take a look at that 4 o'clock region. So yeah, you have some sunspots in there. You have that brighter area, which we call a plage. We also have filaments, which are arced regions that we will see on the limb of the sun. That's the edge. Here we see a couple of them. They look like hairs or pieces of fuzz. They aren't. These are actually what we see on the limb of the sun, but a different view of it as the sun rotates, as it
And
turns.
we've seen, and this is what we've been looking at over the last few weeks, and we've had some, as I say, some fairly major solar activity, and I think even earlier this week there was a very large class X2 flare, maybe, that was sending a whole stack of high energy particles towards us. And it's these active regions, that's where that kind of stuff emanates from. But we've also seen, Keith, you were talking about these filaments, these dark kind of snaky things on the face of the sun. We've seen some extraordinarily long and complex filaments over the last couple of weeks, haven't we?
Yeah, and it has to do again with that idea of the magnetic field, where the plasma is shooting up off the surface of the sun and then looping back down, and we can see it in these filaments. Here's an
Okay. We'll explain it then on this next diagram that we've got. So what are you showing here on this?
Okay, so the plasma, which is that material that we have from the sun, bubbles up from the sun's core, and it carries a magnetic charge and an electrical charge. And as it flows and ebbs and flows in these currents, it will have a north pole and a south pole, and the field lines loop in this arc. For the most part, it can take different forms, like we saw in that other diagram. Sometimes the magnetic field line will be broken, and it'll shoot straight up. Sometimes there'll be clusters of them, and that further complicates things. But this is the basic idea of what's happening, jutting out of one pole and being sucked back down by the other.
Okay. And that's what's happening with those filaments that we're seeing. We're seeing them, on the face of the sun as a dark line. So that takes us on maybe to this image, which is a prominence, which we saw on the first image, but this is an absolutely remarkable prominence, isn't it?
Yeah, so this is what happens when we look at the edge of the sun. Those filaments that we saw, as you said, these snaky, fuzzy, furry-looking lines. This is actually what they look like when they're on the edge. They look like those fuzzy lines when the sun rotates. Here we see them sort of on a face-on view. Just like we see galaxies on Slooh, where a galaxy can be face-on or edge-on. Here we're seeing the whole face of the prominence, and very clearly we can see this plasma, the solar material, being expelled from the surface. And it has some options. If it has enough momentum, it can carry over to the other pole of the sunspot region. If it doesn't have enough, sometimes it'll just collapse on itself. Sometimes it can break away if the field line is broken and just expel out into space. But here we see it arched over in kind of this loop. And this is a classic thing that we look for on the way
And
of the sun.
we have been seeing some, astonishing prominences recently. And when we're looking at this is a snap that was taken from the live video feed from the solar telescope. But when you're watching that live video, some of the activity recently has been so fast. We've been watching these prominences develop, minute by minute. And in fact, it was a couple of weeks ago where I saw, frankly, the fastest changing prominence that I'd ever seen. And I think it was because of what you just said there. The magnetic field line had broken and just released all of this superheated plasma into space. And that, of course, once again, is the kind of stuff that we're going to be talking about in episode 3 of this series, because when those high energy particles hit Earth, it can give us all sorts of problems. Keith, take us through a couple of these other slides, because we've got some pretty special prominences here. This one, we can see the scale of this. Tell us about this one.
Yeah, prominences are that solar feature that we really get excited about. People don't
Mm,
really get excited about sunspots or, filaments until they get to be on the edge of the sun like they are here. I mean, this is just incredible. We have the Earth to scale, so you can see how large these explosions of plasma are. And they are explosions. We think of the sun as being this, nice round ball because, we don't see what's happening on it. We don't hear it. These are explosions. And we can look at something else on this image here too. The granulation. This is that material,
yes.
plasma bubbling up from the core of the sun that has this electrical charge that develops into magnetic field lines, exploding, literally exploding at supersonic speeds. Every one of these millions of explosions leave a sonic boom, if you can
Mm,
believe that. So the sun is an incredibly noisy place, although we don't hear it because sound is in a vacuum, right? So we will feel the vibration, and that's a study all its own. But this
yeah.
prominence is just phenomenal. I mean, it's enormous, it's huge. What's going to happen to this? Will this be drawn by the opposite pole? Who knows? Will it be cast off into space? We don't know. And it's just a beautiful, beautiful thing to look for. And this is what solar observers look to
Yeah.
do.
And we're also seeing two um, incredibly active regions there. When they
Yeah.
brighten like that, that's normally when they are releasing a whole bunch of high energy particles. And we see that kind of brightening. It tends to happen over a period of minutes and can diminish very, very quickly in the view. This is the first time I think we captured two such intensely bright active regions at the same time, but so far away from each other. Have we got any other prominence
Well,
images
let's
to
go back.
share?
Let's just
Oh,
point a couple things out here. Still, the when we see very intense bright areas like that, a lot of times those are actually solar flares. So I wouldn't doubt if you're right. These are highly ionized
hmm,
regions that are casting off material away from the solar atmosphere that will eventually hit Earth. And we do see some other things too. We have some
we do.
filaments again, but just a beautiful image of this prominence. I'm sorry. We can go to the next slide.
Yeah, so this is great. This is an observation that was shared by Carol Botha, and this is kind of illustrating what I was talking about. How quickly some of these prominences and features can change over minutes and hours, Keith.
Yeah, so what she did here, taking pictures from the live solar feed, the live telescope, and seeing how this prominence changes over a period of time. Again, we see that arch, that loop, suggesting that
Mm,
it is being drawn back into the opposite poles in the magnetic field. You definitely see it down on the bottom, 4 and 5. And it's getting brighter, which is also interesting here.
yeah,
So,
yeah,
like you said, these prominences can last for minutes, days. The sun can rotate and it could still be there. And the
yeah,
same thing with sunspots. Some of these active regions, the sun rotates on its axis about once every 27 days. A lot of these active regions will still be there as the
yeah.
sun rotates, and we see it again.
And we see them return, and I love that when I'm controlling the solar telescope. I think we got one other. Um, I think we got a time lapse, haven't we, as well here?
Yeah, this is probably one of the most famous prominence images in the history of Slooh, Paul, that you have done. It shows something that we talk about all the time, pareidolia. The human mind likes to make sense out of abstract images, and this is a perfect case of this. To you, it looks like a woodpecker. It kind of looks like that to me, too. It's kind of hard to not see that, and it is actually going to fly away, take flight off the surface of the sun, and just kind of evaporate. It's an
Yeah, it
amazing,
was
amazing
it was
capture.
great, and
How
and it
did that,
did. Say again, Keith.
how long did you take to, I mean, how long of a period was it for this to transpire?
I think it was about 30 minutes that this
Oh,
was
wow.
going on. So it was very quick, and it's in the morning as well. And that's the best time. Mid-morning is the best time for solar observation. So if you're in North America, try and get up a little bit early one day and have a look at the early morning solar telescope views, because it's when the sun is risen high enough in the sky but hasn't heated up the ground, and as soon as the ground heats up, then you start getting lots of convection, and that can spoil the view. But yeah, I absolutely loved that morning watching that. But anyway, Keith, I want to talk very briefly, because I did kind of hint at it then. The solar telescope works slightly differently to Slooh's nighttime telescopes. Um, so if you are a member or thinking of joining, you schedule missions on the nighttime telescopes where you're selecting a target and to a specific nighttime object to capture your images. With the Slooh Solar Telescope, because it's a live video, you can't schedule it. It's only looking at one object anyway, the sun, and you have to snap images from the live telescope feed. And we'll show you that a little bit later. The telescope typically operates between 10 and 1600 UTC, which is like 6 a.m. to midday Eastern time on weekdays. But make sure you catch up with that. So, Keith, what can members do with their captured images? I'm thinking specifically if members want to learn a little bit more about the sun, we've got some quest learning activities, haven't we?
Absolutely. The Slooh quests are the best way for anyone to learn about whatever it is that interests them. So we have four solar quests. The first is our dynamic star, which is a beginner quest. It's a good place to get started if you know absolutely nothing about the sun.
Mm,
There's another beginner quest, our radiant star. That's a solar quest that requires some images, so you'll be able to use those snapped images that you took from the solar telescope and plug them in. It's really easy to do. There's another quest that's a little bit harder than that, are rotating stars. So we talked about the cycle of how the sun rotates on its axis. Uh, and there's a nice little work through there where you can watch solar features move from one end of the sun to the other as the sun rotates. And then there's Sun Explorer, which is, I'm sorry, I mix them up. Rotating star, dynamic star, are reading star. They're in order of difficulty. So
Yeah,
I encourage everybody to take a look at them. They're a lot of
yeah.
fun.
They are good fun, and you can capture some brilliant images. In fact, um, next week's Slooh This Week video includes a student from Chabot College. There, which one was it? I think it was yes, it was Our Radiant Star, and it was her quest poster that she's created for that, and it's very creative. I do like it. Anyway, make sure you check that out in the weekly Slooh This Week video. Keith, anything else to say about solar features or this first episode?
I encourage everybody to get on that solar telescope and watch some of this amazing solar activity. It's not going to last long, so this is the time you want to do it.
Yeah, it is. This is a year to really make the most of it because who knows, we may have already reached the peak of that solar cycle, so things might start dimming down. But I think we're going to be safe for a few weeks or months yet, aren't we, Keith?
I think so too. We haven't seen enough sunspots yet to reach maximum, so
We haven't. Well, that is it for this episode. Huge thanks to our expert guest today, Keith Moselewski, and to Gretchen Bickett, our events manager and producer in the background. Don't forget, we have got two more episodes coming up. In the next episode, we're going to be looking at some of the solar activity and events that we can't see in the solar telescope, some of which can impact us here on Earth. And in the third episode, we'll learn about why we should care about these events and, frankly, the potentially catastrophic damage they can cause to our satellite and power networks. We'll learn about one such geomagnetic storm, the strongest recorded in 1859. Now, these events will happen again, but are we ready for them? We're going to discuss that too. But for now, that's it. Thanks for joining us. Clear skies, everyone.